Welcome to this micro course on PySpark. In this short course, we will cover what exactly is PySpark. We will go over the architecture of Spark, and we will show you some basics here that you can use right away and start writing PySpark programs so that you can analyze, you can transform, or you can clean up your data. Okay, so let's begin right away. What exactly is PySpark? So PySpark is the Python API for Apache Spark. It enables you to perform real-time, large-scale data processing in a distributed environment using Python. It also provides a PySpark shell for interactively analyzing your data. Okay, long story short, we have this architecture here. At the bottom here, we have Spark Core and RDDs. Spark Core is the underlying general execution engine for the Spark platform that all other functionality is built on top of it. Okay. Spark Core here provides RDDs and in-memory computing capabilities. Okay, so RDD here is a very low-level API. It's extremely difficult to use for complex transformations. So it's not really advisable to use RDDs for your data analysis and transformations and things like that. What they advise you now is to use Spark SQL. More specifically, the data frames that's being provided by the Spark SQL. We will go over this real quick. But again, instead of using RDDs, PySpark actually advises you as a best practice to use data frames, because with that, you can take advantage of Spark's automatic query optimization capabilities when you use the Spark SQL and data frames here. So that's what I'll be covering in this course. I'll be covering all the syntax, all the things that you need to begin your PySpark journey. Okay, so we just covered the Spark Core and RDDs, and we realized this is a low-level API. This is the foundation of everything that's built on top of it, right? Let's real quick cover these guys here, the structured streaming and the machine learning. Okay, so what is structured streaming? So structured streaming is a scalable and fault-tolerant stream processing engine built on the Spark SQL engine. So this guy here, structured streaming, is built on top of just gonna go back, is actually built on top of the Spark SQL engine. Okay, so this is to deal with the streaming data. Like, for example, you have a lot of IoT devices and things like that. You will be taking advantage of something called structured streaming, and if those IoT devices are sending you data pretty frequently, instead of batching, we will be using the streaming, and that's what it's good for. Okay, then we also have Pandas API on Spark. So I don't know if you guys have seen, but you can also do data transformation and data cleanup and analysis using regular Python pandas, right? So here in PySpark world, PySpark does provide you that functionality that, hey, if you want to take your Pandas notebook and you want to convert that into PySpark, you can do that using Pandas API on Spark. Okay, Pandas API on Spark aims to make the transition from Pandas to Spark easy. But if you're new to Spark or deciding which API to use, the recommendation is to use PySpark, okay? Because PySpark has these optimizations and other things and distributed computing, all the other fancy things that PySpark comes with. If you're dealing with big data, go with PySpark DataFrames, okay? So we have one more thing here, Machine Learning Hub, okay? So what exactly is that? So it's built on top of Spark. MLlib is a scalable machine learning library that provides a uniform set of high-level APIs that helps user create and tune practical machine learning pipelines. Okay, long story short, you can do machine learning using PySpark as well. Now, coming to this part here, the first one here, Spark SQL and DataFrames. So this is the one that I'll be going over in this course. I'll be going over all the syntax and analysis and how to do data cleanup and how to select data, stuff like that. I'll be focusing on this guy here, Spark SQL and DataFrames. What exactly is that? Spark SQL is Apache Spark module for working with structured data. Okay, structured data meaning the data has rows and columns. It allows you to seamlessly mix SQL queries with Spark programs. With PySpark DataFrames, you can efficiently read, write, transform, analyze data using Python and SQL. Okay, we will cover both of them. Whether you use Python or SQL, the same underlying execution engine is used, so you will always leverage the full power of Spark. So that's the high level summary of what PySpark does. PySpark again is a Python API for Apache Spark. It enables you to perform real-time large-scale data processing in a distributed environment using Python. And that's all you need to know. Here in this course, we will be focusing on the Spark SQL DataFrames. Okay, so now let's start writing PySpark. Before I start writing my code, I want to quickly go over what exactly is this thing that you're seeing on your screen. This thing here is actually called Azure Databricks, or just Databricks, because this guy right here, Databricks, is hosted on the Azure, which is a cloud provider, just like Amazon has its own called AWS. Google has its own called GCP. In the Microsoft world, it's called Azure, and inside Azure, I have this Databricks. I'll be writing my code here in this notebook here, which is a Jupyter Python notebook style notebook, but it's for Databricks. Okay, you can imagine Jupyter notebook on steroids, and you get Databricks notebook. It has a lot more optimizations, a lot more things that help you write a good PySpark code. Okay. You might be wondering what exactly is PySpark and what exactly is Databricks. I'm going to quickly go over this documentation here. And this will explain you real quick what exactly is happening. So Apache Spark is the heart of the Databricks platform and is a technology powering compute clusters and SQL warehouses. Databricks that we just saw is an optimized platform for Apache Spark, providing an efficient and simple platform for running Apache Spark workloads. So by the way, the company that founded Apache Spark, they also founded this platform called Databricks. They are from the same company, and I'm relying on that right now for this course here. You can run PySpark locally on your machine. There are multiple tutorials out there which you can follow, that how you can run PySpark locally on your machine. But in this case, since I'll be covering a lot more details in future, very, very soon, after this course, I'll be covering how you can do data engineering in Azure Databricks, how you can do machine learning in Databricks and things like that, how you can create pipelines, data engineering pipelines in Databricks using PySpark. So all of those things I'll be going over entire Databricks. I'll be creating a course after this one. So that's why I'm using Databricks platform. It's a pretty amazing platform. If you're interested, subscribe to my YouTube channel. I'm also in the process of making my website, algomatica.com, where I'll be hosting these courses. So you have one-stop shop for everything data. Before we go further, I just want to quickly go over what exactly is Azure Databricks again. So Azure Databricks is a unified open analytics platform for building, deploying, sharing, and maintaining enterprise-grade data analytics and AI solutions at scale. Okay, I know fancy wording, but what that means is that Databricks can do a lot of things. Databricks can do data engineering. What is data engineering again? Data engineering just means bringing in data from the source systems to target system. Okay, and in between you will do some transformations and cleanups and things like that. So that's a very, very high level view of what data engineering is. But after data engineering comes data analysis. So Databricks can do that as well. The notebook that we just looked at, you can run analysis in that. You can actually have pipelines or schedulers that run those analytic pipelines every day if you want to, or whatever time that works for you. So you can schedule your pipelines, or you can schedule your analysis or analytics, as I should say. So you can do all of that in Databricks. You can also do machine learning. You can do AI. You can do a lot of different things, data warehousing as well. Here they say Azure Databricks uses GenAI with Data Lakehouse to understand the unique semantics of your data. Then it automatically optimizes performance and manages infrastructure to match your business needs. I'm not going to go into what data lakehouse is, but in the Azure Databricks course, I will go into that in detail. What is Azure Databricks used for? So as I mentioned, it's used for data processing, scheduling, and management, especially ETL, which is a big thing in data engineering, generating dashboards and visualizations. Yeah, you can actually create dashboards and visualizations in this. Managing security, governance, high availability, and disaster recovery, data discovery, annotation, and exploration, machine learning, tracking, and model serving, and GenAI solutions. So there's a lot of stuff that you can do in Databricks. And Databricks equips you with a lot of different things. As I mentioned, jobs. The jobs are the ones that actually run your notebooks. They can also schedule notebooks for you to run at a specific time, different things. You have Unity Catalog, which is a catalog that helps you with data governance. So you can make sure that, hey, out of 10 employees at our company, only 2 can work with this workspace or this notebook, for example. So you can actually play around with access features. So who needs the access and who doesn't need the access. You can control all of that access and security stuff with Unity Catalog for your data. Data live tables. This is used for creating data pipelines, data engineering data pipelines. We will cover this in Databricks course, not here. Databricks SQL. So this is a very interesting new capability of Databricks, which you can use where your Databricks sort of acts like a data warehouse. Okay, so Databricks SQL brings in the warehousing capabilities in Databricks. Pretty amazing stuff. Photon compute clusters. You don't need to know that what that is right now. But long story short, they're trying to make Databricks into a one-stop solution for everything data. I know Azure has its own things, AWS and GCP, they have their own stuff. But on top of that, Databricks, which is a separate company from all these other big companies, they are trying to create a one-stop shop for everything data. So that's what they're trying to do here. I'm not affiliated with Databricks. I wish I was. I'm not. But I'm only using this platform because it's pretty easy to work with. And you know what? In the job market, this is the platform that they ask for, right? They're looking for Databricks developers. They're looking for Databricks data engineers or data scientists who actually know how to work in Databricks. So it's high in demand in big data world or even just general data world. So I would highly advise you to look into this. I think one of the biggest competitors of Azure Databricks right now is Snowflake company, right? So they are the biggest competitor. These two companies compete with each other, but Databricks is pretty amazing. That's the one I'm using here. It's gonna also be very helpful for you in coming months and in very near future, because that's what they ask for in the jobs. So here I am in my Databricks notebook, and this is where I'll be writing my PySpark code. So before you start writing a PySpark code, you will have to initialize something called a SparkSession. SparkSession is the entry point for PySpark. So we can define our SparkSession using from PySpark SQL import SparkSession. And after that, let's create our Spark object, SparkSession object by SparkSession. And as you can see, I have this IntelliSense here thanks to Databricks, this code completion, but I won't be using that. I'll be showing this line by line. So SparkSession dot builder dot get or create, and this will create our brand new SparkSession if we don't already have one. Since I'm using a Databricks notebook, I do not need to create this SparkSession here. This SparkSession is already provided to me thanks to Databricks. I won't be running this cell here, so I'll be creating one more cell down below, and I'm just going to quickly show you. If I run Spark and I press enter, you will see that I already have a SparkSession in my notebook here. There you have it. So just wanted to show you that if you're not working in a Databricks notebook, you will have to create this session. Okay. So let's delete all of this for now. The first thing that we'll be looking at in our PySpark course will be the PySpark DataFrame. PySpark DataFrame is just like your regular Pandas DataFrame, if you have seen one, consisting of rows and columns. So I'll be creating the PySpark DataFrame here using spark.createDataFrame method of Spark class, and I'll be using a list of rows. Okay, so the first thing first, I'll be importing the rows class, the row class actually. So from PySpark.SQL import row. Okay, after that, let's define our PySpark DataFrame by df. So df equals spark.createDataFrame, and I'll be supplying a list of rows here. Okay, so to initialize the list, square brackets, in there I'll be specifying my row objects, and I'll show you what's going on here. I'll explain what's going on here. So as you can see in this IntelliSense right away, name equals Alice and age equals 15. So the thing on the left of the equals is usually the column name. So name is the name of the column, age will be the name of the second column, and the data inside that column in the first row will be Alice, and for the age it will be 15. Okay, so I'm not going to be using that, but I just want to show you real quick. I will name my columns A, B, C, D, and E. Okay, so A equals 1, B equals, let's say 2.0 is of type float, C equals, let's make this into a string here, D equals, this will be of type date, 2000, 1st of January. Okay, and one more column I'll add, E equals, this will be of type date time. Okay, and 1000, and I'm just gonna keep that. So there you have it. So this is my first row. Let's create 2 more rows. Row, and you know what, I'm gonna take this IntelliSense suggested output here, and let's create 1 more row. Let's copy all that, and I think I have to fix that there. Guess. Okay, so I think everything looks good here. I have 5 columns, namely A, B, C, D, and E, and let's see if we run this and what happens. You know what, I'm just gonna put DF here and let's run it, and as you can see, it's successful. I have my data frame now. Nothing is showing up yet is because by default in PySpark the data frames are lazily evaluated. Okay, so there is a concept called lazy evaluation where when Spark transforms data, it does not immediately compute the transformation but plans how to compute them later. Okay, so there are 2 concepts here in PySpark called transformation and action. I'm going to write this down here for you. Transformation and actions. 2 things. Creating a data frame is of type transformation, so no computation actually happens here, even though you're running DF here, which is very different from Pandas DataFrame. Okay, if you had this into a Pandas DataFrame and if you put this DF there, you will see that output right away. You will see 3 rows with 5 columns and all the values of that data frame right away. Okay, that's not how it works in PySpark. They are not computed right away unless you add an action to it. So if I do something called df.show, which is of type action, .show is an action, you will see your data frame now. So as you can see now, we have this output here thanks to our PySpark action, which is .show. Now we can see our data frame. So again, just to recap, in Spark, when Spark transforms data, it does not immediately compute the transformation. As you can see, we transformed the data here, but it did not actually compute the transformation. But it plans how to compute them later. Okay, when an action such as .show are explicitly called, the computation starts. So that's why PySpark data frames are very different from Pandas data frames under the hood. I want to quickly talk about the schema of our data frame. As you can see, when we ran our DF, we can see the data types that our columns have. The first one was inferred as big int. The second one was double. The column C was string. The column D was date. The E column was timestamp type. Okay, so this was actually done by PySpark. It inferred the data type from the data that we provided, and then it gave us a type of schema. Okay, you can also see the schema if you provide df.print schema method, and if you run this, you will see the schema type, right? As you can see, it's telling us long, double, string, date, timestamp, right? So this is all coming from PySpark by default, but we can also explicitly define our schema here. So you can define the schema of your data frame by passing this argument here called schema, and inside the schema you can actually define your data types here, the column data types here. Okay, so let's say the A will be of type big int, B column will be of type double, column C will be of type string, column D will be of date type, column E will be of type timestamp. Okay, so now we have explicitly defined our data type by providing the schema option here. Now let's run this and let's see if we run this print schema here, what happens. So nothing really changed because this is what PySpark inferred on its own, and it was pretty good at it. But sometimes it's a good practice to specify your schema types explicitly. Okay, so just wanted to show you that. Now one more way of actually creating PySpark DataFrame from Pandas DataFrame. So what I'm going to do here, I'm going to just remove all this stuff here, and let's define our Pandas DataFrame real quick. Let's call it, you know what, let's just remove this so it's all brand new. Okay, so let's create our Pandas DataFrame first. As always, since I'm creating a Pandas DataFrame, let's import pandas spd and pandas df equals pd dot DataFrame. Inside this, I'll be supplying a dictionary. Dictionary has key value pairs, right? So let's again call our columns A, B, C, D, and E. These are the name of our columns. So A will have values. It's providing me here 1, 2, 3. So let's just go with that. It will have values 1, 2, 3. Our column B will have, let's say, values. Okay, let's just go with that 0.1, 0.2, 0.3, and our column C will have values. Let's just make it of type string. Text 1, text 2, text 3. Okay, and the column D will be of type date, right? Let's just provide some random dates here. Just gonna choose that. The ETH column will be, yeah, I'm just gonna go with all that stuff there that they're providing me here. Okay, just gonna choose all that stuff. So we have 5 columns now, A, B, C, D, and E. And these are in our dictionary. This is a Pandas DataFrame. So you know what, let's just run our Pandas DataFrame right away. And as you can see, we have our Pandas DataFrame right away. Very clear distinction between a PySpark DataFrame and the Pandas DataFrame is you don't have to supply any kind of action, right? It right away runs. There's no concept called lazy evaluation, and it runs right away. Pretty good if you're running data analysis for small programs, right? Now we will use this Pandas DataFrame to create our PySpark DataFrame. It's pretty easy. What you can do is you can just do, let's call it Spark DataFrame equals Spark dot create DataFrame. And then in that we will supply our Pandas DataFrame. Okay, so this will take care of converting a Pandas DataFrame into a PySpark DataFrame. Let's run this, and as you can see, it ran. Let's do spark.df and supply this action to see our output. And there you have it. Spark DF is your PySpark DataFrame. Pandas DF is your Pandas DataFrame. So we now just looked at how we can create PySpark DataFrame from Pandas DataFrame. Now let's look at how we can show our PySpark DataFrame in our output once again. We just looked at .show action. .show action helps us display our PySpark DataFrame in our output console. There are some other options that you can use with this .show action. Let's look at that right now. So we have this It's called Spark DF, right? Okay, so Spark DF dot show, and imagine if you want to see this row vertically, the top row, this one here, the first row. If you want to see this row, right now it is horizontal, right? But imagine if this was a long row, it spans multiple screens, and now you want to see that row vertically. You can actually do that in PySpark using, you're gonna specify one, which is our first row, and then you're gonna say vertical equals true. Okay, and there you have it. That's your vertical row for this first row here. It kind of is showing you the output in a bit of a columnar format, which is good if your row is pretty long. Okay, you can also specify here 2, then you will see 2 records now. Okay, so the first row and the second row are showing vertically now. Likewise, if you do 3 here, you will see 3 records. Okay, so hopefully that makes sense. And by the way, as you know, PySpark by default does lazy evaluation. Again, what do I mean by that? In PySpark, we have transformations and actions, right? Creating a data frame is a transformation. Dot show is an action, so we have to always do that. But imagine if you don't want to do that. You're tired of doing it. You're coming from the Pandas world. In Pandas, there is no concept of lazy evaluation. So how you can achieve that Pandas type functionality in PySpark? You can do something called an eager evaluation, which is an opposite of lazy evaluation. So what you can do with that is you can actually specify something like this: spark.sql.repl.eager.eval.enabled. So this will enable the eager evaluation, and by that you will have Pandas type evaluation in your PySpark script. I'm not going to do that here, but there is an option, so you can actually do that if you want to. So I just wanted to show you that there is an eager evaluation as well, and you can do that. Okay, now since we have this Spark data frame here, what I'm going to do here now is to let's explore this again. Spark DataFrame dot show. As you can see, we have 5 columns here: A, B, C, D, and E. How about if I want to show the names of those columns in my output? So you can do that with spark.columns. Okay, and this will show us all the columns that we have in the list format. Okay, it will give us a list of column names. Very useful functionality if you want to see how many columns we have and you want to output the name of the columns using that. Okay, and by the way, you can, if you want to count how many columns you have in your data set or data frame, you can just do length and just wrap that around that, and this will give you the count of the columns you have in your data set. We have 5 columns in this data set, as we know: A, B, C, D, and E, right? And sometimes I use the word data set and data frame interchangeably, but they're one and the same thing in our context here. Okay, so we looked at dot show action. We looked at how we can print out the name of the columns, how we can count the number of columns we have in our data set. So one more very important action that we are going to look at is dot collect action. Okay, we just looked at dot show action, which was able to show and display our output in our console. Now we are going to be looking at our dot collect action. Okay, so it's specified like this, just DataFrame dot collect. And what does it do? It actually is an action operation that is used to retrieve all the elements of the data set from all nodes. So usually in our PySpark or in clusters, we have worker nodes and driver node, one driver node. So all the work is usually happening in the worker nodes, right? So the worker nodes usually bring in, whenever you call this dot collect action, they will bring in all the data and they will supply it to the driver node. Okay, and the driver node will sort of join them together and will show us here in this format. Let's see. As you can see, we are seeing the format of it's a list of rows, right? So we have the first row, we have the second row, the third row. We only had 3 rows in that data set, right? If you remember. So now they're showing up as list of rows thanks to .collect. One thing you need to remember though is we should only use collect action on smaller data sets. So when your data set is small, you should use .collect action. Retrieving larger data set results in out of memory error. So please be mindful of that. Do not use .collect for big data loads. Use it only for exploration and small data loads. Okay. The other option that I like using instead of .collect is .take. Okay. I'll show you real quick. SparkDF.take. This will, if I specify 1 here in the argument, that means it will only show me 1 row. Okay. As you can see, we only have 1 row now, right? This is also an action, by the way, .take, and this is what is heavily used in big data loads and stuff like that for exploration and other things. Okay. If we specify, hey, 3 here, give me 3 rows. That's what that means. Okay. So now, as you can see, we have 3 rows there. Let's see what happens if I specify 4 here. Again, we don't have 4 rows, but it will give you all the rows that you have in your data set. Okay. So we covered .show action, we covered .collect action, we covered .take action. Okay. Pretty useful actions, by the way, because remember, nothing works in PySpark unless you specify an action on your data frame. So now we're going to look at how we can rename a column. Okay. As you can see, we have this PySpark DataFrame here. A, B, C, D, and E are the columns. Imagine I want to change the name of this D column to something else. Okay, how can I do that in PySpark? I can do that with SparkDF dot with column renamed. This will rename our column. And as you can see, it's giving us this this IntelliSense code completion here. As you can see on the left here will be the name of the column. It will take 2 arguments, by the way. The left argument will be the name of the original column, existing column, right? In our case, D, and the name of the new column will go on the right. So let's begin. So let's do, we want to change the name of our column D. Then let's make that into let's make it D new. Okay, and let's show it as well. Okay, because it's not going to show it by default. So as you can see now, we have renamed our column from D to D underscore new. Okay, so this is how you do column renames in PySpark. Having said that, we can also add a new column in PySpark using something called, very similar to with column renamed, SparkDF dot with column. Okay, so what this is going to do is this is going to create a brand new column based on an expression. Okay, so as you can see here in this IntelliSense, is showing us, hey, you can create a new column. We're gonna give a new name here, and the expression is gonna come on the right here, and we will see what that is. Okay, so let's say we have to add a new column called F. So this is the name of our new column, and our expression is gonna be let's say let's pick our column. Let's pick this column here, A. How you can pick a column? I don't know if I showed you that yet, but you can pick a column. You can select a column using DF. Sorry, the name of our data frame here is SparkDF, right? SparkDF.A plus 1. Okay, so that's the expression I'm going with. And I'm going to show that output as well. So what's going on here? I created a new column called F, and that column is gonna be based on this computation here. Take this A column here, this one, and add 1 to it. So add 1 to every single row. Okay, and let's see what we get. And as you can see here now, we have our new column called F that has expression, which is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Okay, so this was our expression, and that got executed pretty well here. So again, you can rename columns, you can add a new column just make sure when you add a new column, you will have to have an expression here, and that expression can be anything. Okay, so that's how you do it. That's how you do column manipulation in PySpark. So now we have this data frame here, Spark DF, right? How can we select columns? We already looked at how we can select columns. We can do that using name of our data frame dot select, and you can specify, let's say if I only want to select columns A and F. I don't think I have the F yet there, but let's do A and B, right? That's how you will select that's how you will select two columns, right? A and B. This is for the column selection though. How can you select bunch of rows? You can select bunch of rows using dot filter method. So Spark DF dot filter, and then you can specify your condition of filtration. So for example, in our case here, in this data frame here, imagine if I only want to select rows where this column is greater than 1, for example. Okay, so name of our column is A, Spark DF dot A. That's how you will choose that column, and we're only looking for values where we will have values greater than 1. Okay, and let's show it, and let's see what we get. As you can see, we only have 2 rows that satisfy this condition here of this filtration condition. You can imagine filter just like a where clause in SQL. Okay, if you have done any kind of SQL, you have where clause in SQL, and that's how you do the filtration in PySpark. You need to have dot filter method. Inside that method, you will supply your expression. It's like a boolean that satisfies some condition, and you will see your output here. So now let's create a brand new data frame that we can use for some more analysis. So I'm gonna name that data frame DF. So DF equals spark dot create data frame. Inside that, I'm gonna supply a list of lists actually, and that's how you will create this data frame. So first thing first, let's assume we have 4 columns here. The first one will be red, the second will be banana. Okay, third column will have value 1, this will have value 10. Okay, so I'm just gonna copy paste these rows here, and I'm just gonna, let's say I have I don't know, 6 or 7 rows in there. So I'm just gonna copy all that and align all this here so it looks readable. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 rows here, and I'm also going to be specifying the schema of this. So this will be of schema. Yep, color is pretty smart. Databricks is already identifying the name of the columns here. So yeah, I'm gonna keep the first name as column, first column name as color, and the second column name as fruit. And you know what, ID, quantity, you know what, let's just keep it as that. Okay, so I'm just gonna go with that, and let's run this. As you can see, it ran. Let's show that data frame df.show, and you can see we have 4 columns here, as expected: color, fruit, ID, and quantity. Right, it has 1, 2, 3, 4, 5, 6, 7, 8 rows here, and we will do some analysis on this now. Okay, so the first thing that I'm going to show you here is the GroupBy clause. Okay, how can you do grouping of your data or aggregation of your data in PySpark? You might have done this in SQL. We can do the similar concept here in PySpark. So we can do df.groupBy, and let's say we are looking for grouping by color. Okay, so let's do group by color. Okay, and let's see what we get. As you can see, we are getting a type of group data, which is pretty good. What happens if I do a show on this? Do I get anything? Not really. because group data does not have has an attribute show. It's always a good idea to play around with things, right? So df.group by color. So we are grouping this df data set by color, and let's do a count on that. Okay, so let's see if this is gonna work. So again, it's not gonna show us anything unless I specify an action here on this transformation. And now you will be able to see your group data set and their counts. So red appeared here 5 times, which is actually interesting. If we can count it, 1, 2, 3, 4, 5. So that's a correct count. Blue appeared twice, black appeared only once. Okay, so again, I grouped this data set by color. You can group this data set by fruit. So I want to see how many bananas are there, for example, right? So you can do that by like this. And as you can see, we have 3 bananas here. We have 2 grapes here. We have 3 carrots there. That's the correct count. What if you want to see something else, not just the count? You can actually also specify an average. So let's say you're looking for grouping by fruit, but then you're looking for their average. Okay, so you can do something like this. Average of what though? Right now we have 2 columns here, ID and quantity. I just want to see the quantity. Okay, so you can specify quantity there, and let's see what we get. And as you can see, we have an average of 33 bananas there. We have 60 grapes, and we have 46 carrots. Okay, and what happens if I actually don't specify the quantity column here? Because right now it's doing the average by quantity, right? What happens if I don't do that? What happens then? So what happens then is it finds these numerical columns, which is ID here and quantity, and then it applies that function on those columns, and we get this. Okay, we have an average of ID, we have average of quantity. So again, grouping usually reduces your data set, and is mostly used for aggregations like this. Okay, so we covered GroupBy. We covered how you can use different functions on the GroupBy, like average aggregation. You can do count aggregation and things like that. So pretty useful, and you use this a lot in data analysis and data engineering as well. So just keep on practicing this. Okay, so far you looked at how you can do data manipulation and data wrangling with PySpark. You looked at group by clause, filtration, how you can select some columns, how you can rename columns and things like that. But what if you want to copy the data frame that you're working with into an external file? Okay, so you want to take this data frame and you want to save this data into an external file, let's say a CSV file. How can you do that? So you can do that pretty easily. Let's say your data frame that you're working with is df, right? So you can do df.write.csv. Inside here, you're going to supply the name of the file. Let's say it's called random.csv. That's the name that you want to give. You can give it any name you want, and you're going to keep all the headers that are coming in from the data frame intact, even in the CSV file. Then you're going to supply this argument here, headers equals true, and this will keep the column names intact. Okay. So this is about writing to a CSV file, but similarly, you can also read from a CSV file. Okay, so you can read from a CSV file by using spark.read.csv, and you're going to supply the name of the file wherever it's saved, the location of the file. Let's say it's just in the same directory, and it's called foo.csv, and then we're going to bring in all the headers as well. So header equal true here, header equals true. By the way, this is also singular here, and yeah, and that's how you're going to read a CSV file. Okay, usually you actually save this into a data frame. Let's say the data frame will be df. Okay, so that's how you can save that external CSV file. This was the external CSV file, and we read that using spark.read.csv, and we saved that into this df variable here in sort of like a data frame for PySpark. Okay, so that's how you do writing operation to CSV and read from CSV. Similarly, you can do the similar, you can use a similar syntax to read a Parquet file, or you can write to a Parquet file as well. So let's begin with the writing part. So df.write.parquet, this write.parquet, and you're gonna again supply the name of the file. Let's say it's bar.parquet. It can be any name you want, okay? And this will save your data frame into a Parquet file. Similarly, you can also read from a Parquet file. Very simple, just like CSV. Spark.read.parquet, and you're going to supply the name of the file or the location wherever that file is. I'm just going to use the same name here, bar.parquet, and that's how you can read from Parquet and save it into your PySpark DataFrame. Similarly, you can do the similar thing for text files, ORC files. ORC file is a file type that's used in Hadoop big data systems. So how can you do that for ORC? So very similar to Parquet and CSV. df.write.orc, and this will write your data frame into an ORC file format. Let's say the name of the file is, let's just go with bash.orc. okay, I think that's the one that's giving us, Databricks is giving a suggestion, and I'm going to go with that. So that's how you write your data frame into an ORC file format. Similarly, you can also read it. You can read the data from an ORC file, just like how we read data from CSV and Parquet. So spark.read.orc and bash.orc, and that's how you do it. Okay, obviously again you're going to be saving this into a data frame or something like that, so we just call it df orc, and let's just make this df parquet so there's no confusion. So yeah, so that's how you read and write to CSV, Parquet, and ORC file formats. So how can we work with SQL commands in PySpark? So far we looked at data frames, right? We looked at how we can manipulate the columns, how we can filter the column, just like a where clause in SQL. But all of that was done in PySpark DataFrames. How can we now treat that PySpark DataFrame like a table in SQL? As you can see here in the screen, we have this DF DataFrame here, which we just created some time ago. It has 4 columns and 8 rows. How can I treat this table as a database table? So the first thing I need to do is to register this DF DataFrame into a database table. So how can I do that? So I'm gonna say df.create or replace temp view, and I'm gonna name my table as, let's just call it fruit table. Okay, fruit table. So this will register this DF DataFrame, PySpark DataFrame, into a database table called fruit table. Let's run this, and now I can use this fruit underscore table like your regular database table, and I can supply SQL commands using spark.sql, and let's just do select star from fruit table. Okay, and let's see what happens if I run this. Obviously nothing's going to show up because at the end of the day, PySpark treat this command spark.sql as a transformation. So I need to apply an action to it, .show, and now you're going to see your table. And there you have it, exactly the same as the data frame here that we just looked at. And now we have this database table, okay, called fruit table. So that's how you can write SQL commands in PySpark. The first thing you will have to do is, again, you will have to register your data frame into a database table, and after that you can use spark.sql, and inside spark.sql you can write SQL commands. One of the topics I won't be covering in this PySpark course is UDFs, which is user defined functions in Python. The reason for that is the UDFs are, as you can see here on this Google search, why to avoid UDFs in PySpark. One of the main issues with UDFs is that they can be slow to execute. Since UDFs are written in Python, they're not compiled like PySpark's built-in functions, which are implemented in Java. So I won't be covering that in detail, but this is a documentation here. This is a Databricks PySpark documentation. As you can see here, develop on Databricks. So we can just go over this real quick. UDFs again are user-defined functions. When you create a function just like this in Python by def squared, then you're returning a square of whatever it is you're supplying to this function. You will have to register after you're done defining this function. You have to register that function, and then after registering it, you can use it in your SQL, or you can use it in your PySpark DataFrame like this here. Okay, in SQL it's just getting very easy. You're gonna just use SQL and then select ID square with Python. That was the name of our UDF here, and you will supply any, I guess, value to it or any row to it, and then it will do the square of that function of that specific value. Okay, so that's how you do UDF. You create a function, register the function, then you start using it in Spark SQL or just the data frames. Okay, this is a data frame example here. You can look into it in detail if you want to, but yeah, just wanted to cover this. So everything is talked about that usually is talked about when it comes to PySpark. UDF is one of those things. Not really advisable to use it, but just in case you want to read about it, you can go here and read about it. Now it's time for a mini project. So whatever we have learned so far, we will be applying all of that in this project. So you might be wondering what dataset I'll be using for this. So Databricks, which I'm using right now, comes with built-in datasets. Okay, pretty neat functionality of Databricks. They come with these datasets, and we can work on those datasets. We can run our analysis. We can do all sorts of things on those datasets. Okay, those datasets are living in Databricks file system. So we can access that Databricks file system using dbutils. Okay, dbutils is a utility package that comes with Databricks that kind of allows us to work with the file systems. And by the way, if you don't have Databricks and you're not working with Databricks, you're working in Jupyter Notebook, then you will have to just follow along, and so that you can learn some things and how I'm doing this project here. But I'll try my best to provide you with this external data set as well. Okay, so let's begin. So the first thing I'll be using is dbutils. Okay, and dbutils, if you run this, it's just a package. Okay, it's a package provided by Databricks. So databricks.fs.ls, fs means file system.ls. If you have worked with Linux before or Unix before, ls means show us all the files that are in that file system. Okay, and if I supply this guy here, let's see what we get. Okay, so we are getting this nice list of file infos here. Okay, you know what, let's just make this pretty by using display, and this will make our output look good. And there you have it, nicely looking output. We have this paths here, and as you can see here on the row 5, I have this dbfs Databricks datasets. This is where Databricks has stored or saved those datasets here. Okay, so I'm just going to use that. So I'm going to instead of this / here, I'm going to say Databricks datasets, and let's run this again. And let's see what's inside that Databricks dataset folder. And as you can see, we have a bunch of datasets here: flower photos, flights, mnemonics, learning Spark, NYC taxi data, NYC taxi with zip codes data. So let's work with this first dataset that we see here, the COVID dataset. Okay, so let's go inside this COVID, and let's see what do we have there. And as you can see, we have these bunch of folders again, and I guess let's go inside this one here, COVID-19 data. Okay, we'll have to find a file to work with, right? So that's what I'm looking for here. So COVID-19 data folder, and we have a bunch of different files here. We have uscounties.csv, usstates.csv. You know what, let's work with this one here, us.states.csv. So us.states.csv, and let's see what we have here. Okay, so that's the file, that's the location of this file here, usstates.csv. And now we know what the location is. Now we can use spark.read.csv that we just looked at, and save the CSV file into our PySpark DataFrame so we can do some more analysis on it. So let's call this DataFrame df COVID equals spark.read.csv, and let's apply this address, okay, inside this, and let's run this, and let's see what we get. It's running. I think it ran successfully. Let's do df covid.show, and this will show us some records here. It's showing me first 20 rows. As you can see, I have interesting. So it assigned column names on its own, right? But I can see we have the column names here. So what can we do? So what can we do here is I can actually specify header equals true, and let's see if that fixes that. Let's run this again. Let's run this again, and there you have it. Everything's fixed now. So we looked at this earlier, so we are applying that logic now. Okay, header equals true. That means the file contained header, and our data frame will also contain header now. That's pretty amazing. Okay, now I want to see the count of this data frame here, or data set here. Like, how many rows do I have in here? Okay, so what can I do? So I can just do df covid.count, and it will give me a count of all the records we have, all the rows we have in this data set. So I have 20,584 rows in this data set. Pretty big data set, not as big as a big data, okay, but we can call this as a decent sized data set. Okay, and here you can see we have 5 columns here: date, state, FIPS, cases, and deaths. Okay, so I want to see the length. How many columns do I have? Right now I can see it. I only have 5 columns, but imagine I had a lot of columns. So what can I do? So df covid has 5 columns, right? Coming back to this again, what can we do here? How about we filter our data set just for the state of California? Okay, so how can you do filtration in PySpark DataFrame? You can just do df covid.filter, and now our condition is, what's the name of this column here? df.state, right? So how do you access columns in DataFrames, in PySpark DataFrames? You do df, the name of the data frame dot state equals California. Okay, and now this will give me a subset from this df covid data frame. And you know what, let's just save this into a new data frame here. California equals, okay, and let's run this now here, df California, which is a subset of our main data set, and let's do a show on that so that we can see what's going on inside that. And as you can see, all the records in this data set now is from the state California. Now what I want to do here is I'm going to go back to my main data set here, df covid. So now you looked at how you can do the filtration, how you can create a subset using the dataframe.filter method. Now I want to do a group by. Okay, so I want to actually count how many times different states actually occur in our data set. So we have df covid, right? So df covid.groupBy, group by state. Yeah, I'm going to be grouping this by state because I want to see the count, how many times California actually shows up in my data set, how many times Washington shows up in my data set. Okay, so I want to do df covid.groupBy, group by what? I want to do a group by state. Okay, and then I want to do, after that I want to do a count on that. Okay, and you know what, let's do a show on that too, so we see our result right away. And as you can see, this is what we wanted. We have everything grouped by the states. So Utah is appearing 381 times in our data set. That's the count that we are getting. Hawaii actually appearing 371 times in our data set. Texas appeared 394 times in our data set. So that's how you use GroupBy clause in PySpark DataFrame. There are some more things that you can do here. Like for example, you can actually sort this count here. How can we do that? So what I'm going to do here is I'm going to use .sort method. Inside that, I'm going to supply my count, and let's see what we get. Okay. And as you can see, all these counts have been sorted now. So the smallest being on the top, because by default it shows the lowest amount, right? But what if we want to see the highest amount here? So we can do ascending equals false. This will give us the most occurred state in our data set. Okay. And as you can see, let's see what state. So Washington actually has the highest amount of records in our data set, then followed by Illinois, California, Arizona, and so on. Okay, so you can do a bunch of things here. So we use GroupBy clause, we did a count on it, we did some sorting on it. So yeah, so that's pretty much it as far as doing this project is concerned. You can do a lot more things to it, but I just wanted to show you how you can actually explore a brand new data set and apply your new learned PySpark skills. If you want to practice a lot more PySpark, I create PySpark, SQL, and Pandas videos almost every day on my YouTube channel, Algomatica. Please subscribe to that channel. I'm also creating my website right now, algomatica.com, where I'll be hosting all these type of courses that are in demand right now in the job market. This was a PySpark course. I'm creating a complete Databricks course for data engineers. And yeah, so that will have a lot of information in there as far as data engineering is concerned, creating data pipelines, data warehousing, stuff like that. So I'm creating that right now. So please follow along. Please subscribe to my channel, and there's a lot more fun stuff that's coming that's in demand.